All right, number 14, we're still kind of talking about our graphs of our functions. Um, f of x is a square root of x function. G of x, we have done some things to it. We are shifting it to the right 2 units, down 4 units. This 1/3 right here, that's going to be a compression because that number is between 0 and 1. It's a vertical compression. So just a quick sketch of what that would look like. If this is the original with the 1, 3, 5 pattern, a vertical compression would look like this. So it would start at the same spot, but it would be compressed vertically, kind of like squished. Okay, so we've got those two functions. First question, what transformations of the graph of f produce the graph of g? Oh, well, we just talked about them, so why don't we write them out? We said we would go to the right 2 units. We would go down 4 units. So that's from this x minus 2 and that minus 4. And then that 1/3, that is a vertical compression by 1/3. Okay, what is the effect of the transformations on the domain and range? So let's just first talk about the domain and range of our square root function. Our domain goes from, it's all the x values greater than or equal to 0. So from 0 to infinity. Our range are all the y values greater than or equal to 0. So again, 0 to infinity. We just talked about domain and range on a graph on the last page. So if you jumped to this problem and you're like, what are you talking about? Go back and watch the graphing video where we had to identify, or on the last page, the video for those graphing problems. The one with square roots, we go into some more details on that. Okay, so what is the effect of the transformation? So if we move to the right 2 units, that's going to affect the x's, which will affect our domain. So instead of all the x's being greater than or equal to 0, now, or maybe I should, this is f of x right here. Now, g of x, our domain, everything shifts to the right 2, including the domain. So all the x's will be greater than or equal to 2. So that means we would go from 2 to positive infinity. By the way, a stretch or compression does not affect the domain and range of your graph. A reflection would, if that was a negative 1/3 and it reflected down, that would affect your range. But a stretch or compression, if you're just, yeah, stretching it or compressing it does not affect the domain or range. All right, so the range, if we are moving the whole graph down 4 units, your range will go down 4 units as well. So the range, all the y values, will be greater than or equal to, now if we're going down 4 units, that puts us at a negative 4. In interval notation, we would say from negative and 4 all the way to infinity is our new range. So here's the domain and range for g of x. All right, now let's get into some equation solving. So solve each radical equation, identify any extraneous solutions. So remember, an extraneous solution is a solution we find, and when we plug it back in, it does not work out. It is a false solution. So for number 15, we've got, let me zoom in a little bit on this one. So what I notice is we have this whole thing in parentheses being raised to the 2/3 power. There's a rational exponent. That's why it's in this unit. But we've got this 0.8 outside. So we got to get into the x's because we're solving for x. It's locked down by a 2/3. We can deal with the 2/3 after we take care of this 0.8. So we're going to divide both sides by 0.8 first. 0.8 divided by 0.8 is 1, which is why it reduces. We're going to carry down our x squared plus 2x plus 110. Let's not forget that is being raised to the 2/3 power. And that equals whatever 20 divided by 0.8 is. I know it's going to be a bigger number because there are a lot of 0.8s will fit into 20, and that actually gives us 25. All right, so our goal is to get to these, but this is blocking us, that 2/3. So what we can do is we can raise this side of the equation to its reciprocal power. If we raise it to the 3/2 power, what that forces us to do is use our power to a power exponent property and multiply those exponents together. 2/3 times 3/2 is 6/6, which reduces to 1. When that reduces to 1, then that just leaves us with x squared plus 2x plus 110. Now, if we're going to raise the left side of the equation to 3/2 power, that's only allowed as long as we do the same thing over here. Raise this to the 3/2 power. So 25 to the 3/2 power, we could do this on our calculator. Also, it's a good teaching moment. What that is that is the second root of 25. That's the root raised to the 3rd power. So I just broke up the root and the power. The second root of 25 is a square root. Square root of 25 is 5. And now we can take 5 to the 3rd power. So 5 times 5 times 5 is 125. Okay, so we have to solve for x. I see an x squared and I see an x. So I'm hoping that we are starting to remember, because we did this in like our second unit last trimester. Anytime you have to solve an equation with an x squared and another x, this is going to be factoring or quadratic formula. Obviously, I'm going to try factoring first because it's way less work. But if you were just like, I have no idea, then definitely quadratic formula. But in order to do either of those, we do need our equation set equal to 0. So we're going to get this 125 to the other side. So we have 0 equals x squared plus 2x minus 15. Okay, so for factoring, it is just an x squared, so we can jump right to our c value. Do we have factors of negative 15 that add up to positive 2? So if we think about our factors of negative 15, 1 and 15, 3 and 5. So it's going to be the 3 and the 5. Because we want it to add up to a positive 2, let's make the 3 negative. Negative 3 plus 5 is negative 15. So we met that criteria. It multiplied to negative 15, and it also adds up to positive 2. So we're going to say x minus 3 times x plus 5 equals 0. And then now that it's factored, we can set our factors equal to 0. We get to use the zero product property. So we get x equals positive 3 and negative 5. Now, we found two solutions. Do we actually have two solutions? So what you do to test that is you take this x, you come up to the original equation and you plug in a 3 for the x here and for the x here. And you just type all this in. If you're using the graphing calculator, you can do this on the calculator and you see if it equals a 20. So I'm going to pause the video. I'm going to check a 3. I'm going to plug in a 3 for the x's. Okay, so when I plugged in the 3 for the x's, I did get a 20 back as my solution. So the 3 worked out. That is a true solution. And then when you plug in a negative 5 for the x's, you also get back a positive 20. So in this case, both solutions worked out. We did not have an extraneous solution. So that equation has two solutions. But it's possible that one of those maybe wouldn't work out, so we do have to check. All right, next problem. we have x plus 6 is equal to the square root of x plus 6. So solving a radical equation, we want to undo this radical. Do we have anything outside? We don't, so we're ready to just jump right in. It's a square root. If we raise it to that power, we can square that side. Remember, when the power and the root match, that does just simplify away, giving us an x plus 6. But if we're going to square the right side of the equation, we have to square the left side of the equation. And here's where we get to the number one mistake I see when squaring binomials. If you guys have x plus 6 squared, and you square the x and square the 6, you get x squared plus 36. That's wrong. An x plus 6 squared does not equal an x squared plus 36. So please be very careful about that. Again, if you have an exponent, if you're raising something to a power that has addition or subtraction, that means it's 2 terms, 3 terms, 4 terms, however many terms, we cannot just bring the exponent in and square. You don't get the same answer. What we have to do is say, well, an x plus 6 squared is really an x plus 6 times another x plus 6, and we do have to multiply it out. All right, so multiplying this out, we get x squared plus 6x plus 6x plus 36 equals x plus 6. We can clean up the left side a little bit. We have an x squared plus, combining like terms, gives us 12x plus 36 equals x plus 6. Solving for x, we have an x squared, so we want to think factoring our quadratic formula, which means get your equation set equal to 0. So we're going to subtract the x, and I'm just going to go ahead and subtract the 6 at the same time. So our new equation is x squared plus 11x plus 30 equals, those add up to 0. Okay, so here's our equation. Factoring or quadratic formula. You know I'm going to factor this because to me that's easier. Do we have factors of 30 that add up to 11? So yep, those factors are just a 5 and a 6. So x plus 5 times x plus 6 equals 0. The zero product property lets us set our factors equal to 0 and solve. So we're getting x equals a -5 and a -6. And now we need to check both of those answers. We plug in a -5 here and a -5 there. We see if the left side equals the right side. Then we plug in a -6 here and a -6 here and see if we get the same thing on both sides. I'm just going to check that on my calculator. I'm going to pause the video, but that's how we check to see if we found true solutions or if either or both of these is a false solution. All right, I'm back and I found that I plugged in both and the left side equaled the right side for both equations. So we found two true solutions. So we did not have any extraneous solutions here, but it's possible that you do. I mean, it happened on the test you already took, so we got to look out for it. We always check our answers. Okay, so number 17. Now we're getting into the last unit of this chapter. This is our composition of functions, function operations. So it says let f of x equal 3x minus 2 and g of x equals 5x. Identify the rule for the following functions. So what I notice is these two problems are very similar. This one just has a 3 here, and this one has an x here. So the one that has the 3, our answer, we're going to get back a number for our answer. The one that has the x will still have x's in our final answer. So this is f of g of 3. It's a composition function, which means we're substituting one function into the other function. You guys have been doing substitution for a few years with solving systems of equations. So remember substitution and elimination. Substitution is when we substitute one equation into the other equation, and now we're doing the same thing, just the notation looks a little bit different. But for this first one, because it's a 3 instead of an x, what we do is we're going to take a 3, we're going to substitute it into the g function. So that's essentially saying, what is g of 3? We always start on the inside. G of 3 is equal to, we go to our g function, and we plug in a 3 for the x, and we get 15. So now we know that g of 3 is equal to 15. So we're going to take that 15, and now we plug it into the f function. So we're finding f of 15. So f of 15, we go to our f function, 3 times 15 minus 2. 3 times 15 is 45 minus 2, and we get a final answer of 43. So remember I said that our final answer would be a number if we're starting with a number right here. All right, so number 18, f of g of x, we are still going to have an x in our function, but what we're going to do is we start on the inside. We're going to take our g of x function and substitute it into the f function. So here's what it would look like. Our g of x function is going to substitute into the f function for the x. So f of g of x is going to equal 3 times, that x is going to get replaced with a 5x minus 2. And then we just simplify. 3 times 5x is 15x. That minus 2 just comes down. So f of g of x is equal to 5x minus 2. That's a composition. All right, so number 19, last problem. Identify the rules for, all right, so this notation, you guys see the open circle. That is not multiplication. That's what we want it to be. We want it to just be a multiplication problem, but it's not multiplication. That is a composition. The way we say it is f following g. It's the same thing as f of g of x. Okay, so f of g of x, we're going to take our g function and substitute it into our f function. So if I come over here, our g function is x minus 1. We're going to substitute it into the f function. So that's going to give us a 2 times, we're going to substitute the x minus 1 in for the x, and then we have that to the third power. And then we're going to simplify this. All right, so up above, I talked about if you have an x minus 1 to the third power, we cannot do this. X minus 1 cubed is not equal to an x cubed minus a 1 cubed. Please, please, please stop doing that. We actually have to multiply this out. An x minus 1 cubed is an x minus 1 times an x minus 1 times an x minus 1. We can start by just multiplying 2 of them out. We have x squared minus x is a minus 2x. So the more you guys multiply out binomials, you might do a step like that in your head. So I just did, hope you don't mind. And then negative 1 times negative 1 is a positive 1. So that's our answer. I combined like terms in my head. I didn't write them down. I'm going to multiply this by our final x minus 1. I'm not forgetting that there's a 2 out front. We'll distribute the 2 in once we multiply out our x minus 1s. So this one I am going to write out. We have x squared times x squared times a negative 1. Now we have negative 2x times x, negative 2x times negative 1, so positive 2x. Now we're going to distribute the 1 times x and 1 times negative 1. You guys know this problem is going to be so fun. All right, so combining like terms, we have x cubed, negative x minus 2x, or minus negative x squared minus 2x squared is a negative 3x squared. 2x plus x is 3x, and then minus 1. I'm going to put parentheses around this and carry down that 2. And our final answer is just going to be, we're going to distribute that 2 throughout. So we're going to have a 2x cubed minus 6x squared plus 6x minus 2. Final answer for that composition. The reason why that one got more involved is because we had a power of 3, but we've multiplied that before, so not a huge deal, just took a minute. All right, last one. Now we have to do G following F. So we're going to reverse it. A G following F is G of F of X. So what that's going to look like, oops, meant to erase, is we are going to start on the inside where we take the f of x function and we substitute it into the g function. So our f of x function is 2x cubed. We're going to substitute it into the g function. So that's going to be replace the x with a 2x cubed and then minus 1. All right, we don't have any distributing or multiplying out to do. We don't have any like terms. So how nice is that? Final answer. All right, there's your ticket to retake the test. I hope that was helpful.